All right, we just talked about how perception takes time. It takes a little bit of time for us to register what's going on in our environment. So let's talk about now how it corresponds more to the distal than it does the proximal stimulus. So what do these terms mean, distal and proximal? So distal means the actual object in the environment, or the sort of the collection of stimuli in the environment. Okay, so for example, in this picture of a door, or when you see a door in real life, right, the actual object in the environment is it's a rectangle, right? So the tops and the bottom, or the top and the bottom are parallel, the two sides are parallel, and the top and bottom are shorter than the two sides. That's usually what a door looks like, right? But in reality, on our retina, the shape of this door projects into this kind of a shape. Okay, but we don't see it that way because we're taking into account all kinds of contextual cues, right? So I've got shadowing here, the fact that the door is open, right? And the shadows let me know that the door is open, and that's why it's shaped this way, right? So I'm taking into account my perspective on the scene and all of the information coming from this scene to let me know that this is a regularly shaped door, right? This is not how I perceive it, even though this is the image that's projected onto my retina. So let's check out an illusion that demonstrates this. Okay, so the actual object in the environment, this is a checkerboard, right? Different colored checkers. There's a column here, it's projecting a shadow across the checkerboard, right? We have square A and we have square B. I'm going to exit out of here so that I can manipulate this and show you, right? So this is just a copy of square B that I made, right? And I just placed it right over square B. Okay, so it's just I made a copy of it and put it right over that. Okay, so now I'm going to move square B to square A. Lo and behold, square A and square B are actually the same color. I'll just do it a couple times for you. So the object in the environment, okay, with all of the cues around it, it's different colors, right? A and B are different colors according to everything that we're taking in from our environment. But on the retina, A and B actually are not different colors. Okay, so let's take a look at this pretty cool little real life demonstration of this same
Tonight,
principle.
I'll be eating loaded tots for March Madness. Thanks, boo. I think you better double them tots. No, this me was last year. I didn't get my madness last year, so we're doing double the madness this year.
Now I want dots. The music is for real. They like did it up with the soundtrack. Okay, so this is not a two-dimensional drawing of a checkerboard, right? This is a three-dimensional checkerboard. They have the lighting set up. They've got the column sitting there on the checkerboard. Okay. Pretty cool little real life demonstration there. You can see that what was actually in the environment we interpret as different to be what was actually projected onto our retinas, right? So let's get back into this and I'll show you another one. These are the shepherd's tables. So imagine you walk into a room and you see two tables that look like this, right? These are very oddly presented tables, right? The tabletop is weird, the perspective is weird, the three-dimensional cues are sort of off a little bit, right? But they're different tables, at least they look different. But if I were to just copy the top of this shepherd's table here, that's all I did, was I just made a copy of this, cut it out just like with the checkerboard, right? So made a copy of the top of that table, flip it around, and put it on that table. It's the same shape. Okay, so once again, what's out in our environment is not what's actually reflected onto our retina. Okay, so that is what we're perceiving to be coming in from our environment is not necessarily what's projected onto our retina. So here's a really cool demonstration of this done in paper.
Believe it or not, these two
Pretty
tabletops
quick.
I drew are exactly the same size. You're going to need proof for this, but you can easily draw this too.
And whoop!
The proof cutout is exactly
There he
the same
goes.
dimensions as the table.
I'll do it again because that's the only time he does it.
You're going to need proof for this, but you can easily draw this too.
Hey!
The proof cutout is
Okay.
exactly the same dimensions as the tabletops as well. The dimensions of both tabletops and the proof cutout are all 4 1/4 inches by 2 inches. Follow the links on this page to
So
get a
you can
copy
do
of the
this yourself.
exact drawing and proof cutout so you can draw
and
it
prove it to
yourself,
yourself
or
if you
feel
still
free
don't
to use
believe me,
mine.
which is very likely. Some of these illusions are like, oh, they're hard. They're hard to overcome. All right. So these are examples of how what's going on in the environment, what we perceive to be going on in the environment, is not an exact copy of what is happening on our retina. Okay, so I remember I told you that visual information splits between visual fields, and we get this retinotopic mapping on our visual cortex, right? So the picture of what's in our visual field is sort of split in half, flipped over, and then flipped upside down, right? And that's sort of how it's mapped onto our cortex. But the relationship of all of the things in our environment to one another makes a difference. Okay, so how those things are organized in relation to one another makes a big difference. Okay, and that's where we will come into the next point, that perception involves active organization of all the sensory information that we're getting at one time, okay, or that we're choosing to perceive at one time. And I will see you in that video.